Okay, so in this video we're going to start our second half of chapter 8. The reason that we split these is because we're looking at rational versus radical functions, and so we like to split the two ideas. We're going to do a little bit of review work. We've kind of briefly touched on this topic. Put a couple examples up here on just this white screen. Okay, and the main idea here is that when I have something underneath a radical, so for example, if I had a term x to the first power, and this is a square root, we generally don't write it, but there's going to be this little square right here that's kind of this little v portion of the actual radical. This is the same as saying x to the 1/2. So we can write it as a rational exponent, okay? And so now if I have, for example, x times y to the 5th, and it's a cube root, I could rewrite this as x to the 1/3, y to the 5/3. And so we can kind of work with this and actually reduce our radicals based on the type of radical we're working with and the exponent. But the main idea that I wanted to focus on in this is just the idea is that we can look at radical functions as a fraction, and vice versa. We could look at these fractions as radical functions. We might have to use this idea in future problems. And so if we look at this next piece, this is a radical function, and we're going to talk about two different pieces here. And I'm actually going to write this in a slightly different way. Okay? And we've talked about transformations before, and I'm going to write it as a different types of situations that will occur depending on where the number is placed. Okay, and we talked about different pieces here. Any number in front of the whole function is going to cause a vertical stretch or shrink. The number with x is going to be a horizontal shift, and this right here outside of the radical is going to be a vertical shift, either up or down. So we've talked about this when we talked about quadratics and other types of functions. Radical here, if I have 3 times the square root of x minus 4 plus 7, the 3 represents a vertical stretch by 3. And remember, for the horizontal stretch, we set it equal to 0, so this will move 4 to the right, and then we have our 7, which causes us to vertical shift up 7. So we're going to move up 7. So these same ideas that we talked about with quadratics and how they shift, we can apply those same principles to the radical functions. Okay, so I'll have a subsequent video after this one where it's the screencast of a calculator with an equation, and we can see how the changes show up on our calculator.